Tick, tock, tick, tock, tick, tock. This clock is talking to you, students. And what it's saying is, can you believe it? But there are always angles in the time. You actually look at an angle and conceptualize an angle every time you look at an analog clock like this. So you can see that you have an end point here, and then a line, and then a section going off to infinity, and then another endpoint and a section going off to infinity, but they're joined here. So what's true is that an angle is just two rays that have a common vertex. The vertex is the center of this clock. And what we can do is take a look at the different special types of angles while thinking about this in the framework of a clock. So I've drawn another clock here, right, just like the one we were looking at. And what we'll do is we'll just take a look at the different ways to draw an angle. So let's imagine that we have the long hand up at 12 and the short hand over at 3, saying that it's 3 o'clock. Okay? So it is 3 o'clock here. Now, what I'm going to do is I'm going to say that this point here is the point V, and then this point up here is A, and this point over here is B, because what we're going to learn is how to actually write an angle properly. Angles have to have their common vertex written in the center. And what I mean by that is we can describe this angle as angle AVB. AVB, with the vertex always as the middle letter. We can also write it the other way around. Angle BVA. These are equivalent expressions, right? They mean the same thing. Again, the most important thing is that you remember to write the vertex as the middle letter. So next what we're going to do is just kind of pull this angle out into this space over here. Right, so here we have A, V, B. All right, this piece in here, or this space in here, is what's known as the interior of the angle. And then the space on the outside of the angle is exactly as it sounds. It's the exterior angle. All right, so it's the exterior of the angle. Whenever we label an angle, we're assuming that it's the interior, though. Now, this angle here is a really special angle because it makes 90 degrees. So this is what's known as a right angle. Right angles are 90-degree angles. Let's look at a different point in time. All right, so we'll erase this. We'll keep our center of the clock here as the vertex. Let's go. Okay, so we get the shorthand labeled here properly. And we say, oh, it's about 310 now. Well, you'll notice that the angle's no longer right. It's no longer 90 degrees. And if I say that this is C and this point below here, B, is D, we would say we'd have angle CVD. So now we have angle CVD. And it is no longer right. If it's less than 90 degrees, it is acute. So less than 90 degrees. So less than 90 degrees is what's known as an acute angle. Let's look at another time measurement here. We'll keep V as the vertex. Let's say, go up here, long hand up to 1. And then this shorthand over just past 8. Right? So we'll say this is X and Y. So now we'll draw this angle. Okay, so we have angle XVY. So angle XVY. What's interesting about this one is that it's more, the interior of it is more than 90 degrees. When you have an angle that measures more than 90 degrees, that's what we call obtuse. So that is more than 90 degrees. Finally, just the best time of the day, without question, is 6 o'clock. I mean, who doesn't like 6 o'clock? Some good shows come on, you're typically eating dinner, time with the family, you're off from school. Who doesn't like a good 6 o'clock? So that's what we're going to put here. The long hand's up at 12, the short hand's down pointing at 6. What you see here, if I put this as S for 6, is I have a new angle. I have angle A, V, S. All right. Well, that's definitely more than 90 degrees. I mean, it's actually a lot more than 90 degrees, and it's very obtuse, but it's straight, right? So it's not just obtuse, it's straight. A straight angle creates a straight line. So it's kind of easy to remember that if you have a straight angle, it creates a straight line. And it is also equal to 180 degrees. We know if we go all the way around a circle, we have 360 degrees. So this straight angle in a clock almost makes like a diameter of a circle, cutting that circle in half. So half of 360 degrees is 180 degrees. So now we have our 4 special types of angles. We have an acute angle, which is less than 90 degrees. We have a right angle, which is exactly 90 degrees. An obtuse angle, which is more than 90 degrees. And then finally, a straight angle, which is equal to 180 degrees. So what we can do here is now use this information to solve problems. So if I know that angle BCD down here, angle BCD, you'll notice that C is my vertex, so it goes as the middle letter. It's a right angle. Well, I know right angles are equal to 90 degrees. So the whole thing is equal to 90 degrees, and it's made up of 2 components. So the angle addition postulate says that it is true that if you take 2 components of an angle and add them together, you'll get the whole angle. So we know that we have angle BCA that equals 6x minus 3. And if we add that to ACD, or 4x minus 7, we'll get a true statement. So we have 90 degrees is made up of 2 components, angle BCA and angle ACD. Right? And if we use substitution for their values, we come up with something algebraic. Speaking of algebra, let's do some. So we have 90 degrees. You can simplify on the right side. 6x plus 4x gives us 10x. And negative 3 plus negative 7 gives us negative 10. Now, do more algebra. We add 10 to both sides. So we now have 100 degrees equals 10x. We can then divide by 10 on both sides. And we get x equaling 10. Well, that's not the exact answer. We wanted to figure out what each of these individual angle measurements was. So we'll input 10 back in. So 6 times an x value of 10 minus 3. That gives us 60 minus 3. So angle BCA is equal to 57 degrees. 4x minus 7, I'll do down here with more space. 4 times an x value of 10 minus 7 is 40 minus 7, which is 33 degrees. And would you believe it? 57 degrees and 33 degrees makes 90. So indeed, BCD is a right angle, and that's how you check your work. Thanks for measuring angles with me today.